Hi everyone, we're going to evaluate the integral, the definite integral over the interval 0 to 1. So let's get started. Our integral is from 0 to 1, square root of x squared plus 1 dx. So we're going to use trigonometric substitution. It has the form of this one with the plus there. So in this case, we're going to let x equal tan of theta. And that's where our restrictions are between negative pi divided by 2 and pi divided by 2. That just means we're in quadrant 1 and 4. And so then our derivative of x is going to be secant squared theta d theta. All right, so now we have to change our bounds. So when x is 0, tan is going to be 0. So that stays 0. When x is 1, that means the angle for tan is pi over 4. So this will be pi divided by 4. And so we can substitute this right here for, well, let's deal with that. So basically, we have x squared plus 1, and that's going to give you secant. Well, let's do that. So if we let this be x be tan, we get tan, square root of tan squared theta plus 1, which equals the square root of secant squared theta, which equals secant theta. And it's we don't have to put absolute value signs in because of our restrictions. So basically, when you substitute this, you're going to get secant, and this should be pi over 4. This is going to be secant theta times dx, which is secant squared theta d theta. So this ends up being the interval 0 to pi over 4, secant cube theta d theta. If I do a little triangle here, and I have my angle here, so if we have x equals tan of x, then that's going to be tan is opposite over adjacent. So this is going to be x divided by 1, and the hypotenuse is just going to be this. If you do the Pythagorean theorem, you'll get x squared plus 1. This is a right triangle. Now the thing is, this, integrating this, in particular this piece, is a pretty lengthy process, and I already did it on another video. You need to know how to do this because of it occurs in applications a lot. So if you haven't watched this video, please watch that. So to integrate that, the answer would be 1/2, and then you're going to have secant theta tan theta plus ln of secant theta plus tan of theta. So that's the antiderivative of secant cube theta. And we want to evaluate that from 0 to pi divided by 4. So that's going to give you 1/2. And let's start with pi over 4. Secant of pi over 4 is square root of 2. Tan of pi over 4 is 1. And then plus ln of 1 plus square root of 2. Or you can switch those around. And then when you plug in 0, you're just going to get minus 0 for this part. And when you plug in 0 here, you're going to get minus ln of 1 minus 0. And that's it for that. Now remember, ln of 1 equals 0. That's because e to the 0 equals 1. So if you took ln of both sides, you get 0 ln of e equals ln of 1. So ln of 1 is 0. So we were left with 1/2 times the square root of 2 plus just this part here, plus ln of 1 plus square root of 2. And that's your final answer. Thank you. Have a nice day. Bye-bye.